I'm going to explain this. Here you can see that the order of the matrix. First of all, I told you that you must see the order of the matrix. Here, the order of this matrix is 2 into 2, 2 rows and 2 columns. Here, there are 2 rows and there are 3 columns, 1, 2, 3. So here I told you that rows and column. Before multiplication, you will have to see that the column of the first matrix, that the column of the first matrix must be equal to the rows of the second. So these two must be equal here. They are equal, so we can multiply these two. First of all, you have to check this. Now, if they are equal, here there are 2 columns and here there are 2 rows. They are equal, so it means we can multiply. Now you can see that this is 2 minus 7. This is the first column of the second matrix. This is the first column of this second matrix. This first column is 2 and minus 7. So this first column, 2 minus 7, will be placed like this. I have mentioned this. Just look at again. 2 and minus 7 will be multiplied like this. 2 multiplied by 4 and minus 7 multiplied by minus 9. In this way, we have to multiply, and there will be sign of addition in between this multiplication. Look at it very carefully, how I am going to do. Adi, you also? Previously, I am multiplying the first column. First of all, I am taking the first column of the second matrix like this, 2 and minus 7. I have written on the piece of paper. So I am multiplying it like this: 2 into 4 minus 7 into minus 9. And you know that 2 into 4 gives you 8. Minus 7 and minus 9 gives you 63, positive 63. Now you have done with this row. Now the same thing will be done with the second row. Minus 5 and 2 gives you minus 10, and 10 sevens are minus 70, like this. The multiplication of the first column is completed. We have done the multiplication of the first column. First of all, while doing the multiplication of the first column, you can see that I have placed positive or negative signs according to the signs of these elements. Okay. Now you will have to leave the space because you have another column. When you have another column, then you will have to leave the space because there is another column. According to this column, we are going to make another column like this. Now the other column is minus 3 and 0. This is minus 3 and 0. This is the second column. I have written this column on the piece of paper for the sake of convenience: minus 3 and 0. Now again, the same thing I am going to do like this. 4 threes are minus 12, minus 12 like this, and then 0 into minus 9 gives you 0, plus 0. Okay. Now in the same way, minus 3 and minus 5 gives you positive 15, and 0 into 10 gives you plus 0. So this is the multiplication of the second column. The first column make the multiplication of the first, and the second column making the second column. Now let us consider the third column. Third column is 5, 8. I have also written this third column on the piece of paper for the sake of convenience: 5 and 8. This is the third column. Third column is going to make the third column for the resulting matrix also. Okay. So again, the same procedure is going on like this. 5 fours are 20, and minus 9 into 8 minus 72, and then minus 5 into 5 gives you minus 25, and 8 into 10 gives you plus 80. Now you can see that I have multiplied rows and column according to this. You will have to follow this rule because this is the basic rule which you must follow. Now you will have to add or subtract according to the given signs. 63 plus 8 gives you 71. Minus 10 and minus 70 gives you minus 80. Minus 12 plus 0 gives you minus 12, and 15 plus 0 gives you 15. And then you can see that minus 72 and plus 20. Minus 72 and plus 70. Oh, sorry, minus 72 and plus 20. What is the answer? Minus 52. In the same way, 80 and minus 25. What is 80 minus 25? Gives you 55. So this is the resulting matrix. While multiplying these two, here these two matrices are cannot be multiplied. As I told you, the order of the matrices here, these are 2 rows and 2 columns. Its order is 2 into 2. The order of this, 1 row and there are 2 columns, 1 row and 2 columns. As I told you, rows, column, rows, column. You have to check this first of all. First, the column of the first matrix is not equal to the rows of the second. So these cannot be multiplied. This is not equal. This is the sign for not equal. They cannot be multiplied because the column of the first is not equal to row. Another thing, very important thing which you must learn, if this were be written like this, like if I am writing like this, 2 and minus 3, very important thing which you must observe. Please observe it carefully. If I am writing in a different way, the second matrix I am writing first and the first matrix I am writing as second, in this way. Now here the order was 1 into 2, the order is 2 into 2. Now they can multiply. Now you can multiply these two very easily, as I told you that the rows and column, rows and column of the first is equal to rows of the second. These are equal. So here in this order we can multiply, but in this order not possible. Not possible. In this order it is not possible, but here it is possible. And now you can multiply it yourself that how they are possible. Okay, I have told you in the many examples that how you are going to multiply the matrices, because I told you that the column of the first is equal to the rows of the second, so you can multiply it yourself. This will be, well, this is the question number 7 of exercise 5C. If these two matrices are multiplying with each other, this is the sign of equality is equal to this. Find the value of P and Q. We have to find out the value of P and Q. I am going to write this question on the piece of paper. Well, the first matrix, which can be read as 1, 5, and the lower row is 3, P. Those who can solve, they can solve it themselves. Those who are finding it difficult, they can observe it very carefully. Okay, this is that how we are going to solve this. As I told you that first of all you have to multiply. You can see that these two matrices are going to multiply with each other. This is Q and 7. I am writing it like this, Q and 7. This is, as first of all you have to check the order of the matrix. It is 2 into 2, it is 2 into 1, so they can be multiplied with each other. Okay, so here we are going to multiply. We are going to multiply the same procedure. This is Q and 7. This is 1, 5, 3 and P. Okay, so as I told you that this is the column of the second matrix. I am placing it like this, 1 into Q, this is Q. 1 into Q gives you Q1s are Q and 5 7s are 35. There is a sign of addition between them. In the same way, 3 Qs are 3Q plus 7 Ps are 7P. This is the matrix after multiplication is equal to 50 and 35. Now you can see that you have two matrices which are equal to each other. You have to make two equations. The first equation equalizing the upper rows to each other. Okay, equalizing these two and equalizing lower rows also. In this way, we will be able to make two rows and then we can solve them simultaneously. Q plus 35 is equal to 50. From here, we can find out the value of Q. So Q is equal to 50 minus 35. 50 minus 35 gives you 15. So the value of Q is 15. This I have solved from the first row. Now take the second row, which is 3Q plus 7P is equal to 35. Okay. Uh, Solution. You can see that here the value of Q is 15. I am substituting this value of Q is equal to 3 into 15 plus 7 into P is equal to 35. Now you can see that 15 threes gives you 45. This is 45 plus 7P is equal to 35, and 7P is equal to 35 minus 45 gives you minus 10. So P is equal to minus 10 over 7. In this way, you can very easily find out the answers carefully. I am writing I matrix. Normally, we write I for the identity matrix. I for identity. Please listen to me carefully. That I stands for identity matrix 1, 0, and 0, 1. This is the matrix of order 2 into 2. So here, this is called the identity matrix in this case. So identity matrix basically its property is this, that if you are multiplying any identity matrix with any other matrix, then let us see that what is going to be done. This is called identity matrix and it is written like 1 0 0 1. In question number 9, he has used this identity matrix. Now you have to observe that how this identity matrix is showing you the multiplication. In question number 9, he has shown you a matrix A, 8, minus 3, 7, and 5. This is the matrix A, and he is asking you to evaluate in the first part A into I. Mean first A, keep A and matrix A and then I. So I am also writing in the same order. First of all, I am writing the matrix A, which is 8, minus 3, 7, and 5. And then I am writing the identity matrix 1, 0, and 0, 1. Again, the same rules of the multiplications will be applied. As you know, that is 1, 0. I am writing it 1 and this is 0. The first column, first of all, you can see that these are both the orders are 2 into 2. So they can be multiplied with each other. So 1, 0. I am writing it like this. So first of all, I'm doing the multiplication with this first column like this. Look at carefully. 1 into 8 gives you 8. 0 into minus 3 gives you 0. 1 into 7, 7 ones are 7, 0 fives are 0. Now come to the second. Second one is the 0, 1. I'm writing it here 0 and 1. This is 0, 1 column. The multiplication of the first column I have done. First of all, I did the multiplication of the first column. Now I am going to do multiplication of the second column, which is 0, 1. Now again, leave the gap here and then you will have to write down 0 into 8 gives you 0. Minus 3 into 1 gives you minus 3. And 0 into 7 is 7. 5 ones are 5 plus 5. Identity matrix is the same. It has the same values. Whenever you are going asked to write down the identity matrix, you have to write down like this 1 0 0 1. For the order, this is the identity matrix of order 2 into 2. Okay, there may be another identity matrix of some other orders, but here we are going to discuss the identity matrix of 2 into 2. Okay, now we have to do it. 8 plus 0 gives you 8. 7 plus 0 gives you 7. Minus 3 is minus 3. And then here, oh, sorry, this is 0. this is 0 actually, because this we were multiplying, no? Look here, this 0 1, while multiplying this 0 sevens are 0. Okay, 1's 5's are 5. Now 5 plus 0 is 5. Okay, now you can see that this is the same whatever the a, this is a, this is equal to a. You can observe that if we have multiplied with identity matrix, you got the answer a. So there is no difference whenever you are multiplying with an identity matrix, your answer is not changed. So a will remain a. So keep this mind, like if you are multiplying any number with 1, for example, 25 multiplied by 1 gives you 25. 6 multiplied by 1 gives you 6. Here, like this 1 has the property that if you are multiplying any number with 1, the number doesn't changes. In the same way, if you are multiplying any matrix with identity matrix, it doesn't change. Okay, this is a into I. Now let me do in the reverse order, that I into a. This is the second part of the same question, in which he is asking you to find out I into a. Now let me show you the second part also. In the second part, he is asking you to find out I into a. Now you have to leave the identity matrix first. Identity matrix 1001. This is the identity matrix. And then I am writing the A matrix, because first I and then A. You have to keep the order in mind that it is written I and A. Here A into I, so A will come first and I will second. Here I is coming first and A is coming second. -3 and 5. Now let us do the have learned for the multiplication. I'm telling you again and again for the sake of convenience. This is the column 8 7. I am writing it like this on the piece of paper for the sake of convenience, like this. This is 8 7. This will multiply like this. Look at, observe it carefully. 8 ones are 8 plus 7 zeros are 0. 8 zeros are 0, 7 ones are 7. This is the multiplication of the first column. So first column comes. With the multiplication of the first column, you got a first column. Now the second column. Come to the second column, which is -3 and 5. I am writing it here, -3 and 5. This is the second column. Now you have to leave the gap here to multiply with the second column. -3 into -1 gives you -3. 5 into 0 is 0. -3 into 0 gives you 0. 5 ones are 5. Now do the addition or subtraction, whatever is going on here. 5 plus 0, oh sorry, 8 plus 0 is 8. 7 plus 0 is 7. -3 plus 0 is -3. And 5 plus 0 gives you 5. Now again you can see that whether you are keeping the order different, I into a or a into I, so this is again equal to a. So here you are finding out that the identity matrix has the property that if any matrix is going to multiply with an identity matrix, the matrix is not going to be changed. You must keep this property in your mind. We are going to do. He is asking that is a square equal to a square, b square, c square, d square. He is asking that whether this a square equal to this. Okay, now you will have to tell me that whether this a square is equal or not.